Let's look at this problem. Professor Chang has 9 different language books lined up on a bookshelf. 2 Arabic, 3 German, and 4 Spanish. How many ways are there to arrange the 9 books on the shelf, keeping the Arabic books together and keeping the Spanish books together? Good. This problem is not so hard if you know how to build a mathematical model. It is obviously a counting problem. And in this problem, we don't have any casework because it's quite straightforward. Since we are going to line up the 9 books on the bookshelf, right? We are not going to align them on different levels. It'll be on the same level. And we have 2 Arabic books and 3 German and 4 Spanish, right? But we want to keep the Arabic books together and Spanish books together. So we can think of, we have a magic glue such that we glue the 2 Arabic books together and take it as if one. And then, let's say, these are the 2 Arabic books, right? I just call that A. We glue them together. And then we glue the 4 Spanish books together. All right, so that's S. Now let's do the ranking or permutation of the 9 books. No, it's not 9 books anymore. We have 1 super Arabic book here and 1 super Spanish book here, and plus how many? 3 German books. So we have 5, let's call that imaginary books on the bookshelf. Then how should we arrange these 5 books? So certainly we have 5 factorial. That is the number of ways we rank these 5 super books. 3 regular and 2 super books. So are we done? Of course not. If you don't believe so, we can even give it a try. Actually, this problem didn't set up any trap for us, because we know this 5 factorial equals 120. So if it has a choice here, let's say F, 120. So that may trap some students. Then you may wonder what's missing here. Actually, we miss a lot. Let's look at this super Arabic book. Is there any subtle place in it? Of course, because when we glue the 2 books, there are different ways to glue it. Let's say the first Arabic book can go to the first. Let's call this A1, this A2. So A1 can go to the left, or A2 can go to the left. Therefore, we have 2 ways to glue this super Arabic book. So this 5 factorial got to times 2, multiply A2. And similarly, we are not done yet. For this Spanish book, we have 4 regular Spanish books glued together. But there are multiple ways to glue these 4 books. And how many ways? Of course, that's a permutation of 4 books. Then we multiply 4 factorial. Good. So this is our final answer. And how much is that? Let's do the calculation. So how do we do that? So of course we can multiply this 1 by 1 and expand the factorials, right? 5 factorials, 1 times 2 times 3 times 4 times 5. And then we do it sequentially. And there could be other ways to do it. Let's look at it this way. So that actually equals. Let's take 5 out and combine that 5 with this 2. So we have a 10. So 10 times 4 factorial square. All right. So 10 times, what is the 4 factorial? That's 24 square. Now, 10 times, we break this again. because at least this is for me. If you remember what is the square of 24, right? And then you can apply that immediately. Then you get the answer a lot faster than me. The only thing I remember is 12 square. Therefore, I'll separate this further. So that equals 2 times 12 square. And that is 10 times 2 square times 12 square. So that equals 2 square, that's 4, times 10, that's 40, times 12 square. As I said, I only remember the square of 12. So that's why I do it this way. So times 144. And this equals a 0. 4 times 4, that's 16, carry a 1. 16 plus 1, 17, carry a 1, 4, 5. That's 5760. That's our answer. So the choice is C. If you like this video, please subscribe the channel and thumb up. If you have questions, please comment.